Welcome back to Math with Miss Swartz. Today we're looking at slope. So we know what a line looks like, or a linear equation on a graph looks like. So what we're going to do is start working with that graph and determine some information from that graph that can help us, well, one, graph easier, and two, understand our graph a little bit better. So our essential question is, how can we use the slope of a line to describe the line? So slope, just to give you an idea, is when we're talking about the steepness of a line, how steep a line is. Okay, so we've worked with some different types of lines like this, okay, with our arrows. And we want to talk about the steepness of that line. So how fast is it going up and down, essentially? How steep is it? So we're going to look at this first slide here. It's got a definition of slope and how we're going to work with it. So slope is also called M a lot of times, and you'll find that why we call it M out tomorrow, should be tomorrow. But the slope of a line is a ratio of the change in y's, okay? So how much the points move up or down, the rise is what we call that, and then to the change in x's, or the run, so how much it moves side to side. So if you think about how we graph a point, we actually graph, okay, if I were to graph like 1, 2, I would go to the right 1, up 2. Okay, well, this is actually the opposite when we're trying to find the slope. We're actually considering the y's first, how much it's moving up or down, and then how much it's moving left or right. Okay, so between any 2 points, x1, y1, and x2, y2 on the line. So if this is our x1, y1, and this is our x2, y2, we're looking at how much this point, okay, moved up to get to here. That is maybe some number, okay, 2. And then how much it moved over, and it's a ratio, so it's like a fraction, so maybe it moved over 3. So 2/3 in that case would be the slope. The slope is represented as a number, can be represented as a fraction. There's lots of different ways to think about it. So this gives you another picture, and rise over run is a really good way to think about slope, because that makes you think, how much does it rise? Okay, it might go down, but that means it's still, was going up or down a certain amount. How much did it run? How much did it go side to side? Another way to think about it is the change in y's. Okay, so you can represent that like this: y2 minus y1. That's how much y's have changed over the change in x's. x2 minus x1. That's how much the x's have changed. We have 2 types of slope. We have positive slope. Okay, so make sure you have this in your notes. The line that rises from left to right. Okay, so here's the left side, and it's going up from left to right. And then we have negative slope, the line that falls from left to right. So over here is our left side, and it's going down from left to right. Okay, so this slide is super important. Make sure you have everything on this slide written down. And then we're going to look at some examples. All right, our first examples here, they kind of give us some help because they draw the lines in for us. But we have a point at -3, -1, and we have a point at 3, 4. And it says, describe the slope of the line and then find the slope. When it's asking to describe the slope of the line, it wants to know if the slope is positive or negative. So in this case, our line is rising from left to right. So this is going to be a positive slope. So our answer when we find the slope should be positive. Okay? So remember, now we're looking for the rise over the run, or the change in x's over the change in y's. Well, when we have a picture, we don't necessarily need to work with the points as much as we just need to look at the graph, and we need to figure out, all right, how much did we go up to this point? So my rise is going to be 1, 2, 3, 4, 5. Okay, and I even wrote it over here. So that's 5. And then how much did I run? So from this point to this point, how much did I move over? So 1, 2, 3, 4, 5, 6. So my slope is a positive 5, 6. Okay, remember this tells us how steep the line is in regards to like one hole would be pretty steep. So this is about 5, 6, so that's pretty steep as well. Okay, describe the line here. We're falling from left to right, so this is going to be a negative slope. Okay, so our rise is a little bit of a different story because now we're falling, so it's not necessarily a rise, but essentially we can still look at it that way. So we're going to count how much we moved down in this case. 1, 2, 3. Well, we moved down 3, so that's going to be a negative 3. Over how many we moved over. So 1, 2. It's going to be 2. So our slope is negative 3/2. So again, pretty steep. Anytime you're able to simplify slope, you should do so. But in these cases, they're already simplified. Okay, let's look at some more examples. All right, now we don't have those lines to help us. It says find the slope of the line, so we're looking for rise over run. Okay, so first of all, determine, okay, it doesn't ask for this, but determine is it going to be positive or negative, because that's going to help you kind of gauge what your answer should be. So in this case, we're falling from left to right. Here's the left side, here's the right side, it's going down. Okay, notice the difference here where left side, right side, we're headed up. Okay, so I'm going to count how many my points move down. So if I count this, I have a negative 1 there. And then I'm going to count my run, how many I moved over to get to that point. So 1, 2, 3, 4, 5. So my slope would be negative 1/5. Now you see that's not as steep of a line. It's kind of more shallow. Okay, rise over run here. So we're going to count how many we went up. In this case, we have that positive slope we were talking about. So I can count the rise, 1, 2. If that picture helps. And then over 1, 2, 3, 4, 5, 6. All right, so here's our first example of we can simplify that to 1/3. Okay, so our slope would be 1/3. So any other point on the line, probably, okay, I go up 1 here, over 3. Up 1, over 3. Your slope is always consistent. Okay, again, positive or negative slope. This is going up from left to right. So it's going to be positive, and then we're going to count the rise over the run. So I'm going up how many? 1, 2, 3, 4, 5. And then over to the right, 1, 2. That's simplified. Okay, so pictures are what you're going to be working with mostly for today. We are going to look at one other way we can find slope, and this is maybe a little bit more difficult, but as we move forward, you're going to have to be able to do this. So let's take a look here. Oh, I forgot. Sorry. Now, we talked yesterday about horizontal and vertical lines, so we want to talk about the slopes of horizontal and vertical lines. Okay, so if we think about this, this is a horizontal line at 5. Okay, so it looks like this, y equals 5, because our y coordinate is always 5. Now, our slope here, if we were to consider our rise over our run, whenever we have a horizontal line, if you think about the rise of this, okay, are we moving up at all to get to here? Okay, so if we just are coming from here to here, did we move up at all? No, and if you have a horizontal line, you're actually never going to move up at all, so your rise would always be 0. And then your run, you might have some here. So 1, 2, 3, 4, 5, 6, 7. But your rise will always be 0. So what will the slope of that horizontal line always be? 0, because 0 over anything, no matter how many spaces you move over, is going to be 0. So the slope of any horizontal line is going to be 0. So let's look at vertical then. If we have a vertical line, okay, our rise over our run, this would be like x equals 4. Okay, we can count the rise. We're going to go up 1, 2, 3, 4. But when we go to count the run, we always would end up with 0 because we weren't moving side to side at all. It's always at 4. Now, this is a very tricky thing for a lot of 8th graders. Can you divide by 0? So let me ask you this question. If I gave you 4 M&Ms and told you to divide them into 0 groups, could you get an answer to that? Well, I hope not. That doesn't make any sense. So, any vertical line has a slope that is undefined. All right? So all slopes for vertical lines are undefined. All right, we're kind of running out of time here. So we're going to look at one example of just having the points. We'll do more with this tomorrow. But if we're just given the points and we're not actually given a graph, obviously you could graph this. But what I want you to remember is slope is the change in y's over the change in x. Okay, so the change in y's is also represented, we wrote this on the first slide, as y2 minus y1 over x2 minus x1. So what we have here is x1, y1 and x2, y2. So what we could use is this formula, plug in our numbers, and find the slope that way. And we're going to be doing that more and more. So I'm going to take what I have. Y2 is negative 2. Y1 is negative 2. X2 is 7. And x1 is 1. So then I just do the math. Negative 2, I'm going to do keep, change, change. So negative 2 plus 2 would be 0 over 6. Well, in this case, then my slope would be 0, which probably means that this would be a horizontal line. Okay. So just one more example for you. I'm going to jump down to... Actually, we're going to call it a day. We'll do more of those tomorrow, just because I don't want to throw too much at you, and I'm just going to have you look at graphs on your homework today. So, we'll talk about your homework once you get your notes checked. Have a wonderful day. See you soon.